Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions, and today we will start the concept of functions. Understand the definition first and then we will understand the definition using an example. Let A and B be two non-empty sets, alright. Then a function from A to B, this is the way we represent a function f from A to B is a relation, alright. So function is basically a relation. You know what is a relation by now. You know the Cartesian product, that is the cross product of two sets, and then you know the relation is a subset of the cross product. Now a relation, a special type of relation is called a function. Now what are the conditions a relation must satisfy so that it should be called as a function? So these are the two conditions a relation must satisfy. Now first of all the elements of the first set A are related to some elements of A. The important thing is all the elements of A must be related. All the elements, there should not be any element left in A which is not related, alright. Secondly, no element of A is related to more than one element of B. So one element must be related to only one element. One element should not be related to two or three elements of B, understand? So if you have a relation, let us say you have a set, I'll take 1, 2, 3 and I'll define a relation from A to B. I'll take B also. So let me take 1, 4 and 9. Right. Now let me write a relation. The relation being 1, 1, 2, 4 and 3, 9. Well, so I'll draw the arrow diagram for you. So this is the set A and this is the set B. We are defining a function. Let me name it as f itself because it is a function. It is a relation as well as a function. Okay. So all the functions are relations basically, right? Now you have A 1, 2, 3 and in B you have 2, 4, 9. 1 goes to 2, 2 goes to 4, 3 goes to 9. Understand? Every element is related and every no element in A has more than one element in B which is with which it is related. Alright. So no element is related to more than one element of B. No element in A is related to more than one element in B. It is related to only one element. Now I'll just change my this one set. I'll write 1, minus 1, 0 and 2, and here I have 1, 0 and 4. I'll include one more 1 and here I will have only 1 and 4. Alright. Then I'll define the relation like minus 1, 1 and 1, 1 and then 2, 4. See how am I defining? I am taking f of x is equal to x square, alright. So f of x is equal to x square. That means you have the elements in A and that are minus 1, 1 and 2. You can take as many elements as you want. I have taken just few elements here. Now minus 1, square of minus 1 is 1, square of 1 is also 1. Now 2 goes to 4. Is it a function? Yes, it is a function because every element is related, first condition. Second condition, no element is related to more than one element of B. See, understand, minus 1, is it related to two elements of B? No. 1, is it related to two elements of B? No, it is related to only one element. Okay, so it is also a function, it is also a function. Now, when do you think it is not a function? Let me give the example for that also. You have 1 and 4 here, and you got minus 1, 1 and 2 here. Okay, so then let me define the function as 1 comma minus 1 and 1 comma 1 and then 4 comma 2. Now how is it? Now 1 is the square of minus 1, 1 is the square of 1, 4 is the square of 2. So the function is square of. So f of x is x is, see, f is defined like this, set of all x comma y, where x is square of y. Alright, so x is square of y. Now let me draw the arrow diagram of it. Then you will have a situation of this sort. You have 1 and 4 here, and minus 1 and 1 and 2. So 1 is the square of minus 1, right? And 1 is also square of 1, 4 is the square of 2. Now is it a function? Now is it a function? Obviously it is not a function, because you have one element related to more than two elements of B. No element of A should be related to more than one element of B. One element, one image. See, this is called the image, this is called the pre-image, right? So the element has two images. Element should not have two images. Two elements can have one image, that is accepted, but one element should not have two images. This is not acceptable. Therefore this is not a function. This is not a function. If you are saying y is the square of x, then it is a function. Alright, keep that in mind. So let's continue and understand a few important functions. You have already learned identity function, constant function, polynomial, rational, and then modulus, signum, and greatest integers. So here I will concentrate only on modulus and then greatest integer. Signum function is also easy, it's not a big deal here. Alright, so only thing that you have to understand is modulus and greatest integer, and most of the students have a difficulty in understanding greatest integer. So let's just clarify that, and then let's move on to the next concept. So we have just understood the definition of function and the meaning of it. Now in this class let us understand different types of functions, importantly modulus function. How this modulus function is defined? See, mod makes everything positive, keep that in mind. See, modulus of x is minus x if x is less than 0. For example, if x is minus 2, then minus of minus 2, eventually it will be plus 2, right? And if x is positive, if x is greater than 0 or equal to 0, then it is x. Alright, so basically you must have always a positive quantity. So this is 3 because x is negative. If x is negative, what is mod x? Minus x. So here x is minus 3, hence it will be 3 here. So if it is 4, then it will be obviously 4, there is no change, okay, because if x is positive, then you have to write x itself. So that's how you get always positive in mod. So in the graph, if you see, you will never get negative y-axis. Okay, you will never get a values here. You will always get above the x-axis. Okay, so either positive side of x or negative side of x. See, y is equal to x is this graph, y is equal to minus x is this graph. For x less than 0, y is equal to minus x. For x greater than 0, y is equal to x is the graph. So both are diagonal lines there. So understand the graph. Then these are the few properties of modulus function. See, a is always less than or equal to mod a. Okay, it will be less if a is negative, and if a is positive, then it will be equal. Then a will be equal to mod a. So imagine you have 1 is positive, correct? So 1 is equal to mod 1 is also 1. But if you have minus 1, see, understand, if you have minus 1, that will be always less than or equal to mod minus 1, because mod minus 1 is 1 and this is minus 1. That's how it is. Okay, so remember that property. And the next property is see, modulus of AB, that can be written as mod A into mod B. There is no problem, it will be always equal. But if you have modulus of A plus B, then these are not equal. This is less than or equal to mod A plus mod B. Alright, when it will be equal? If AB is positive. Okay, so when AB will be positive? If either both are positive or both are negative. Alright, then what is modulus of A minus B? Okay, that will be modulus of mod A minus mod B. Okay, and that will be greater than or equal. It is not equal. Okay, so modulus of A minus B is greater than or equal to modulus of mod A minus mod B. Well, here also equality holds if AB is positive. Either both A and B are positive, or both A and B are negative. Let's move on to the next function. The second important function is greatest integer function, and how it is denoted, it is written within square brackets. Alright, and what is the meaning of it? It is the greatest integer. So this is greatest integer of z on the left hand side of x. Understand, if x is 1.5. Alright, so if x is 1.5, then what is f of 1.5? Greatest integer of 1.5. See, what is it? It is the greatest integer on left hand side of x. What is x? 1.5. So 1.5 is here. What is the left hand side? This is the left hand side of 1.5. Alright, so left hand side, when you go, what is the first integer you come across? 1. So that is the answer here. And in other words, you can understand in this way also, it is less than or equal to x. What is less than or equal to x? The greatest integer of x. Now what is greatest integer of 1.5? 1. And that 1 is less than or equal to 1.5. Alright, so that cannot be greater than, it should be always less than or equal, and it is the greatest possible integer. Greatest possible integer, but less than or equal to 1.5. So this is the other way you can understand. It is on the left hand side of x. So you get what is the first integer you get on the left hand side of 1.5? That is 1. Now what about if you have negative? So that is very important to understand, because most of the times you don't understand that. See, if I take minus 0.5 here. Okay, so this is minus 0.5. Now you have to go to left hand side of x. Left hand side, what is the first integer we get? Minus 1. Therefore greatest integer of minus 0.5 is minus 1, not 0. Okay, so if you have 1.5, 1.6, 1.7, 1.8, it is 1. If you have 0.1, 0.2, 0.3, it is 0. If you have 2.1, 2.2, 2.3, what is the greatest integer of it? 2. But if you have minus 0.5, minus 0.6, minus 0.7, you have to go to left hand side. You should not write 0. It is minus 1, left hand side. Okay, so keep that part in your mind. So positive, there is no problem, but when you go for negatives, keep this in your mind on the left hand side of x. Well, now what is the domain? Domain means the input values, the values that you put here. So in place of x, you can take anything. See, we have taken real numbers, okay, decimals, correct, negatives, positives, everything. So you can put any real number. So that means you can take any real number along x. But when you get the answers, you get as integers only, you don't get decimals here because it is greatest integer. Okay, the answers, the output that you get is always z. Okay, it's always z. Well, now come to the properties. The first property is see, greatest integer of x plus greatest integer of minus x. You have two different answers there. So why do you get two different answers? Let's check. The first, I'll take an example of 2.1. So if x is 2.123, let us say, okay, then what is greatest integer of 2.123 plus minus 2.123? See, this is equal to what is the greatest integer of 2? On the left hand side it is 2, and on the left hand side of minus 2, okay, so minus 2 is here, so minus 3, minus 2.123 is here. On the left hand side you have minus 3. All right, so that is minus 1, correct? It is minus 1. Why are we getting minus 1? Because x is not integer. Now let's check what will happen if it is an integer. So I'll take 2. So if I take 2, then what do I get? That will be greatest integer of 2, and this is minus 2. So greatest integer of 2 is 2 itself. Okay. On the left, on the right, you don't have to look, that itself is the answer, correct? What is the greatest integer of minus 2? Greatest integer of minus 2 is also minus 2. So hence you get 0 here. So when do you get 0? If it is an integer, not an integer, then you will have minus 1. And if you have any integer here added to x, you can take that integer out, there is no problem. See, if you have 2.123, you can write this as 0.123 plus 2, correct? Okay, what is the greatest integer answer here? What is the greatest integer answer here? That is 2.123, 2, left hand side, right? And see, this can be written as greatest integer of 0.123 plus 2. We can take that integer out, k. All right, now what is the greatest integer? 0.123. Greatest integer 0.123 is 0, and this is 0 plus 2, and that is also 2. So both are same. So we can use this property. All right, we can use this property. But if the integer is multiplied, then you cannot take it out. So that will not be equal. You need an example? Yes. So the example is, I'll take 4.123. So that is nothing but 2 into I'll multiply. Okay, so 246, so that is 2.123, correct? If 2 is multiplied. Now see, we should have two different answers now. All right, see, here the answer is on the left hand side, it is 4. Now if I take 2 out and multiply with this, then this will be 2 into 2, which is 4. Here the answer doesn't change, but if you take negative, let us say, all right, negative. Now I am taking minus 4, then what is the answer? Minus 5, correct? So minus 4.2 is here. On the left hand side is minus 5, correct? So it is minus 5. Now this is also negative, and this is negative. So that means 2 into what is minus 2 point something, that will be minus 3, and that will be minus 6. So this is minus 5 and that is minus 6, it's not equal. See, if it is positive it is equal, no problem, but when it comes to negative, this property does not hold good. So you cannot take that k out if it is multiplied. If it is added, obviously you can add it outside separately, there is no problem. So if you remember those properties, when we go to the problems where greatest integer is involved, it will be very easy to understand. So let's understand next how to find the domain and range of a function. In a relation we have understood already. In a function when we come, how do you find it?
Don't forget to like our video and subscribe our YouTube channel for all the updates.